Hello, good afternoon everyone. Okay, myself Samir Mandal, a Prime Minister Research Fellow in the discipline of mathematics at IIT Madras. Today is the first live session of multivariate calculus. Okay, so 1 minute, wait. I'm going to share my screen. Okay, this portion is, I think, looks fine. Yeah. So basically we are already familiar with single variable functions. Okay. So could you please tell me what is single variable functions?
Y equals to f of x, sir.
Yeah, single variable function. Okay. So it's fine. Okay. So suppose f is defined from D is a subset of R. Okay. And is image also in R. Okay. Suppose x goes to your y. Okay. Suppose and this is your assign one rule. Okay, so f of x equal to y. Here your x is independent variable and y is your depend on x. Okay, this is your single variable functions. So now we are talk about two variable functions. Okay, two variable function f of xy. Okay, so take one domain D which is subset of R2. Here it was subset of R. Okay, for single variable functions. Okay, for two variable functions our domain is from R2. Okay, and we are assigning one rule from D to R. Okay, such that xy is goes to z, means your f of xy equal to z. Here your x and y are independent variable. Okay, variable, and z is depend on x and y. Z is dependent variable. Okay, so for every xy in from your D. Okay, for all xy from your D, which is a subset of R2. Okay, so I am writing here. Yeah, so if for every xy, okay, belongs to D, which is a subset of R2, there exists a unique real value z. Okay, according to some rule f of xy. Here your here your this f satisfies some conditions. Okay, so if for every xy belongs to D, which is a subset of R2, there exists a unique real value z according to some rule f of xy. Okay, then your f of x comma y is called real valued functions of two variable, okay, of two variable x and y, okay, and is given by as your z equal to f of xy for all xy belongs to your D, okay. So what is the difference between your single variable functions and two variable functions? Your domain for single variable function, your domain is from R, okay, and for your two variable function, your domain is from R2, okay. For in two variable function and one variable function, there is one correspond between your domain to your range set, okay. Is it fine? Please tell me. Okay, so similarly one can define a function of n variable, okay. Similarly we can define a function of n variable, okay. A function of n variable, that time we will take D, okay, is from Rn, okay, and it will goes to R, okay. Here your x1 x2 up to xn is related by some rule, okay, with the unique element z, okay. Here your x1 x2 up to xn are independent variable, okay, independent variable, and z is dependent on your x1 x2 up to xn, okay. Okay, so now I have one question for all of you. So till now we has discussed about one variable functions. Basically that time we has our dimension was only one, okay. So right now we are talking about n variable function, or suppose fixed on two variable or three variable functions. So what is the needed of extension of more generalized dimension, okay. So why we are looking for more than one dimensions here? Could you please give me some example of such functions which is depend on two or three independent variable or four? Could you please give me some example, real life example, definitely not mathematical. Why we will study this multivariable calculus? Could you please tell me some example? Please try. So I am giving you one hint. Suppose you are in Rome, okay, and anytime, okay, sometimes someone asks you what is the temperature of your room on a particular point. Please try to think and tell me. Please try someone. Suraj?
Try करते sir.
Hmm? Sorry? Suppose you are in. Please tell. Okay. So you are in room, okay? And in your full room temperature may be fixed or may be vary due to something. Okay, so someone is telling that real world is three dimension. Okay, so therefore position is given by three independent variables. Fine, but if you properly think, we are alive in four dimensional in the sense of space time. Okay, so three independent variable is say about your positions and time t is this variable t is sorry
Space time.
yes space we are in space time. Yes, so here this three variable is tells about your positions and this variable is tell about time. Okay, so suppose you are in room and in your room some wall is somehow some source is there that produce some heats. Okay, so you will observe that wall temperature will be around this wall temperature it will be higher than your another wall temperature or corresponding that one. Okay, and this source may be reduced after few some times also, so that time again your room temperature will be come down and it will be in full temperature will be almost equal. Okay, so rapidly our temperature may be changed. So in full room, okay, the temperature is maybe vary and this depend on time also. Okay, so if someone tell you at 5 o'clock what is the temperature of what was the temperature of your room, okay, and or 2 o'clock or some position it near about that wall which wall was uh, near about some source of heat and which wall is far away from that one. Okay, and so in full room your temperature may be vary. Okay, this is one particular real life example. I think this has many application is in engineering physics, so I think everyone are familiar with that. So this is one basic motivation for us to study your multivariable calculus. Okay, is it fine?
Meaning of 4D, sir.
Sorry,
Position. Meaning of 4D position.
I could not understand, please repeat.
Meaning of 4D position.
Minimum
Meaning of 4D position.
odic position, what is the spelling of I could not understand. Please write in message.
So growth rate of population is also a real life example.
Yes, yeah, agree. So there are many examples. So this is our main motivation to study, okay, multivariable calculus. So we'll start with limit of okay 4D minutes. Someone asked. So here is space times you can think about 4D because here three variable is your three variables is indicate your positions and t is your parallel time space. Okay, so this combination you can think about 4D, this combination space time, this one you can think about 4D. Okay, and I am telling about one thing. Suppose in your 1D, okay, length of sorry, weight of this one is 0. Okay, when you think about 2D, weight of every face or every face is 1D. Here your face was nothing, face was 0. Okay, in 2D your face, suppose 2D one, you have one 2D picture, every face will be 1D, and you have one 3D picture. Okay, so every face will be in two dimensional. Okay, and if when you go for 4-dimensional, 5-dimensional, this is my assumption, not assumption, this is my opinion, and we can think like that. When we go for 4D, your every face will be in 3-dimensional. Okay, you can generalize this concept. For 1D your face was nothing, 0. Okay, for 2D your every face was in 1D. Okay, for when you go for 3D, you can look that your every face is in 2D. Okay, when you go for 4D, your every face will be in 3D. Is it or not? Is it clear? Okay, so now we'll discuss about what is the limit of a function. Okay, now we'll discuss about limits. Okay, here we will discuss about limit of two variable functions. Okay, we already are familiar with what is the limit of a single variable functions. Could you please tell me, what you have one function defined from D, subset of R to R. Take one point, fixed point from D. What do you mean by that function has limit at a point A? This is for one variable functions. Could you please tell me what is the limit of a function at a point A? No, I am telling about what is the meaning of limit of a functions at a point A for a one variable function.
E plus E minus define the limit.
Okay, suppose take this is your function f. Okay, fixed a point A here. Okay, so we are telling that fx approaches to one real number L. L is a real number. Okay, fx approaches to a real number L when your x is approaches to A. Okay, so we'll say that L is a limit. Okay, we'll say that L is a limit of a function f at a point f if for any given epsilon greater than 0 there exists a delta positive such that, okay, your x minus, whenever your x minus a is less than delta, this will imply f of x minus L is less than epsilon. Okay, suppose this is your L. Okay, and your x minus a less than delta means your this quantity a minus the delta a plus delta, this interval. Okay, and your this one is represent like that, your L minus epsilon, this is your L plus epsilon. So this means in that interval, okay, this is your modulus of x minus a less than delta. Whenever your distance between x minus x and a is less than delta, your distance between your functional value f of x and L always should be less than epsilon. Okay, your epsilon is given and we have to find a delta greater than 0. Okay, understood or not? This is a definition of limit of for one variable functions. Someone can observe that suppose if you take one lesser delta, suppose take this one, okay, then same epsilon will be work for this one also, is it or not? Because you are taking small, definitely this is in less than epsilon, a functional value and distance between functional value and L are in less than the in between here, means it's less than epsilon. Okay, and in similar way if someone can take the larger epsilon, okay, sorry, this one, if someone take the larger, okay, larger epsilon value, that time same delta also will work, is it or not? It's fine, it's fine for everyone.
Yes.
Okay, yeah, so this I'm giving you one problem, okay, it's right now it's little bit difficult to verify that function limit of function is does not exist till now. Using this definition, okay, using the definition we can verify that one function or a limit of a function exists at some particular point, but using this definition verify that function limit does not exist is little bit difficult. So till now wait, I will come back to this question soon. Okay, so try to solve one example. Okay, try to find what is the limit of this one. Tends to 0 0 4x y square divided by x square plus y square. What is the limit of this one? Okay, please try to solve this one. Someone can guess what will be the limit of this function? Zero. How?
Sir, it is indeterminate. Y बराबर mx. Y बराबर mx.
Then what you will get? One minute. Okay. Here we discuss about limit of a function of one variable. Okay. Similar way we can define the limit of a functions for two variable. Okay. Before going to this example, I want to mention that. Okay. Yeah. So I should write the definition of limits for two variable functions. Okay. Definition of limit for two variable functions. Suppose we have one function is defined from D, which is subset of R2 from R2 to R, function of two variable. The limit of f of xy as xy approaches to AB, okay, is L if and only if, okay, corresponding to each epsilon greater than 0, okay, there exists a delta greater than 0, okay, such that for all xy belongs to D with 0 strictly less x minus a whole square plus y minus b whole square less than delta, we have modulus of xy minus l less than delta. These two definitions are fully similar. Okay, for one variable functions, this is you are getting one interval, this quantity. Okay, x minus a less than delta, this one getting one interval like that. For two variable we are getting one dx. Okay, this is your dx, is it or not? For your one variable case, we was getting one interval. Okay, yeah, here please try to look that this is strict inequality. Okay, this one 0 less modulus of x minus a less than delta. This one also. For two variable case, we are getting one dx around the point AB. Okay, like that we'll get suppose this is your AB, we will get like that. Okay, is it fine? And for one variable case, we was getting one interval. Is it fine or not? Please tell me.
Fine, sir.
Yeah. So for two variable case, the limit of two variable function, okay, when your xy is approaching to some value AB, okay, xy may be anywhere from here. Okay, suppose xy is coming from this AB. Okay, one can observe for one variable there was only two directions. Suppose this is A, there was only two directions, from this one and from this one. Okay, this one can approach from this side or this side. But for two variable case, there are infinitely many directions. One can approach from here to here, one can approach from here to here, one can approach from here to here, one can approach for this direction also. So for two variable case, there are infinitely many direction is there, but for one variable only two direction was there. Okay, so when your limit of a two variable function will exist at a point AB, so for any epsilon greater than 0, there if there exists a delta greater than 0 such that this condition, when this condition will be happen, okay, this one means your, if you draw one dx around the point AB, okay, with the radius is less than delta, you must have satisfy the function that modulus of f of x minus l, means distance between functional value and l is less than delta. Then we will say that f of x limit exists and limit is l. Okay, but using this definition is little bit difficult to show that the function does not exist the limit at a point. Okay, so we'll come back to this question later when the function limit does not exist. So my question is right now, what is the limit of these functions? Okay, please at first please tell me what is the domain of this function. What is the domain? What is the domain D here of the function? Please
X minus
what is
minus 0.
yeah, r2 minus 0 0. We have to remove the point 0 0. Okay, if we put 0 0, this will be 0 by 0 form. Okay, so right now where we are removing this 0 0 point from r2. So this is your domain of these functions. So my question is right now, what is the limit of these functions? So this function is not defined at 0 0. We are curious about what is the limit of a function at the point 0 0. Okay, if function is already defined and both sides is defined, then it's fine, limit will be that one. But if this is from this case, this function is not defined at the point 0 0. So we are curious about what is the limit of this function at the point 0 0. Okay, please tell me, please guess at least what would be the limit of these functions. So take x-axis. X-axis means your y coordinate is 0. Okay. X coordinate can be anything, y coordinate is 0. X is take and take also x is non-zero. Okay, here. So for this case, and take your f of xy is this one, this quantity. Okay, f of xy is this quantity. So what we will get? F of x comma 0, what we will get? Put the 0 here, then we will get 0. Okay, 0 or not? For this one we will get that f of x comma y equal f of x comma 0 equal to 0. Is it or not? When your x is non-zero. Okay, and also similarly we will get that this one is also 0. Okay, for y non-zero. So from here could you please guess what would be the limit for these functions? Someone can guess? Please guess what would be the limit for this function?
0, sir.
0. Yeah. So we have to prove it. Okay. So what is our guess?
0, sir.
Yeah, we guess that the limit would be 0. This is our guess. Okay, this is the disadvantage of the definition of limit. You have to, at first you have to guess the limit, then you have to verify that this your guess is correct or not, because already we assume that the limit of the function will be L or will be exist. Okay, so if this condition happen, so already we are assuming. Okay, so with them we have to prove that this is a limit or not. Okay, so right now our guess is 0. Okay, so from definition what will be, we have to assume that one epsilon greater than 0 is already given. We have to find a delta. Okay, is it or not? Let's start with that epsilon greater than 0 is given. Okay, so what is our aim? Aim is we have to find a delta. Okay, so how we will find a delta, or in which way? So we want to choose or find, okay, choose a delta greater than 0 such that the following sentence become true. Which sentence? If this satisfied, okay, if this one is satisfied, then your functional distance between functional value and 0 should be less than epsilon. Is it fine? Now this is our aim. We want to choose a delta greater than 0 such that this sentence is true. Okay, means in this dix, if we choose some xy in this dix, a functional value and distance functional value and 0 always should be less than epsilon. Okay, we have to choose one delta. Is it or is fine? Please tell me. So this one is already given, x square plus y square less than epsilon. We have to find only delta. Okay, in terms of epsilon. Okay, is it fine or not? Please tell me.
Yes, sir.
Yeah, so one can observe that mod of y square, here in here we have x into y square. Okay, so our aim is to bound this one with something and this one is with something. In this is the clever things, you have to bound this one and this one in terms of this one, because your dix is this one. Okay, this is your dix. So x square, we already know that root over x square plus y square is less than delta. We already know this one. Okay, so anyhow we have to try to bound this quantity and this quantity in terms of x square plus y square. Is it fine? Did you get my hints? Please respond. Did you get the trick or not? Please tell me.
Yes, sir.
Yes. So for this one we can write this one, because x y modulus of y square and y square is same. This is your less than equal to x square plus y square. Is it fine? And similarly also
Yes, sir.
we can write this one, which is less square x square plus y square. Okay, now come here. This is suppose if this is one equations, so from here we can write that 4x y square plus y square less equal to 4 of modulus of x, which is less equal to 4 into, yeah, please tell me, till now is fine or not? Is it fine?
Yes, sir.
Okay, we put the value of y square. Okay, then we get this one. After that we are putting the value of mod of, not value, this is the upper bound of mod of x. Okay, this one. Okay, now okay, so now one can choose the delta. So please tell me, what is your guess about delta? What should be delta? Please tell me right now. Every information is here. Please tell me, what is your delta? What should be delta?
X square plus y square less than delta.
Yeah, it is already given. It is already given, this one. So you have to find delta. You have to find
Epsilon by 4, sir.
epsilon by
4.
yes. So this is the obvious choice. Okay. So now you have to verify. Okay. So this is your delta. So from definitions, what is your definition? Definition have to satisfy, na? So in this dix we have to get this one. In this dix we have to get this one. Okay, we already choose that delta is 4 by epsilon, and we already got that this quantity is less equal to 4 into x square plus y square. This is less than 4 delta, which is equal to epsilon. So in this dix we are getting this one. Okay, so what is the limit of the functions? Limit of the functions when xy is approaching to 0 0 is 0. Is it fine? Please tell me. Is it fine? Yeah. So can I go in next?
Yes, sir.
Okay. So we are already familiar with the uniqueness of limit. Okay. So for one variable function, if limit exists, limit must be unique. okay, for two variable also. Uniqueness of limit, this is same as one variable. Okay, suppose you have one two real valued functions, okay, defined on some region D, which is subset of R2, okay, and if the limit exists, it must be unique. This is true for n variable also. Okay, so one observation is there. Initially I already discussed about that. For one variable, suppose this is your function f, one variable function, okay, f of x, okay, this is a point A. So there was only two direction approaching to A, okay, but and here is your domain is one interval, okay, but in two variable, suppose this is your dix around the point AB, okay, so there are infinitely many directions to approach to AB, okay, is it fine or not? Please tell me. Is it fine? These two concept is clear for one variable function.
Yes, sir.
Yeah, so approaching to the point A, there is only two direction was there. For the reason, in one variable we used to tell that if your right limit exists, left limit exists, both are equal, their limit is exist. We are familiar with this notation, I think, everyone. F of x, if this one exists, okay, if this one exists, and if your left limit also exists and both are equal, then limit exists and limit is equal to L. So there was only two direction approaching to A. Okay, so same concept is must be satisfied by your two variable function also. Means when we are approaching to point AB in any direction, okay, so if suppose the function limit exists, then when will come from all direction to AB, that limit must be exist and it should be equal to that limiting value L. Understood or not? Please tell me. For this one, for one variable function, when we are approaching from right side to A, okay, so that limit may or may not exist. When we are coming from left side, may or may not exist. If both exist and both equal, then function, the limit of the function is exist and equal to that equal limit. In converse is also true. If limit of a one variable function exists at a point A, then both right limit and left limit exist and both are equal and equal to the limit of the functions. Okay, so same concept is true for two variable function also. Means for two variable function, when we will approach to a point AB from any direction, okay, so suppose the functional limit of function exists, then all when we approach to any direction, in every direction limit of that function should be exist and all should be equal and equal to the limit of the main functions. Okay, so from here in opposite direction we can get like that. Suppose someone okay, please tell me what is your question. Question is, so it would be applicable to n variable function? Yes, yeah, it's also applicable for n variable function also. Okay, so now we can think about that. If all direction in all direction limit of a function exists and all are equal, then limit of function is also exists and equal to that one. In one can think like that. If suppose we are get two paths, okay, so this is one path and this is also one path, and both are going to the point AB, okay, and when we are approaching to this point we are getting the functional value L1. When we are approaching from this path, we are getting the functional value L2. And if L1 is not equal to L2, then we done. Means that time we can say that if the limit of the function is does not exist. Is it or not? Please tell me. So using the definition of limit of a function to show that limit of the function is not exist is little bit difficult. But if someone use this concept that you have one path and in that path the limit of the function is L1, and we have another path that in that when the function is approaching to xy is approaching to in this path and your limit of the function is L2 and L1 L2 both are different, that time we can say that limit of the function is not exist. Is it fine?
Yes, sir.
Yeah. So now we can try one example. Okay. Okay, so take one example. By x square plus y square when your xy is non-zero. Okay, so what is the limit at the point 0? This is my question. What
Not
is
exist, sir.
why? Why? Please tell me why.
Y equal to mx. तो mx के भिन्न वैल्यू के लिए भिन्न fx y वेरी करेगा.
Okay, you are taking y equal to mx. So what we'll get? We'll get f of x comma this one 1 minus m square divided by, yeah, this one we are getting. Is it?
Yes, sir.
Yeah. Yeah. So if you vary the real number m, okay, then this limit will also vary. Okay, suppose take m equal to 1. Okay, then what will get? Will get 0. Okay, if you take m equal to 2, then what will get? Minus 3 by 5. Okay, both are not equal. Okay, when we are approaching with this line y equal to x, when we are approaching this line we are getting the limit is 0. Okay, when we are approaching with this line we are getting this limit is minus 3 by 5. Okay, so we are getting two paths, this one and this one, and in both path, okay, in y equal to x path we are getting the limit is 0, and y equal to 2x path we are getting limit is minus 3 by 5. So and here 0 is not equal to minus 3 by 5, so the limit of the function is not exist. Okay, is it fine?
Yes, sir.
Yeah, and one can check also x axis and y axis. So if suppose goes if someone goes with x axis mean y equal to 0, if someone put y equal to 0, what will get? We will get 1, limit is 1. Okay, if someone put that x equal to 0 means in your y axis, that time we will get minus 1. Okay, this is the basic this few are basic paths, we can easily use those paths. I have one example. Yeah, this one, try this one, this will be interesting. Okay, example 3, take your f of xy equal to xy square divided by x square plus y square. Yeah, please tell me what is the limit of these functions at the definitely at the point 0 0. Okay,
fx xy equal to 0.
limit you are telling limit is 0.
No, sir. fxy equal to 0 per question.
No, I did not. I don't know anything here. For 0 we don't know. Okay, so my question is limit is exists at the point 0 0 or not?
Okay, sir.
Yeah. At first check the limit exists or not. Then if someone go for continuity, that time we have to define the value of function at the point 0 0. Okay, right now we don't know the limit exists or not at the point 0 0. So at first you have to think about that. Okay, so you have one basic path, either x axis, y axis, and third one is y equal to mx. Okay, so put y equal to mx. Then what we will get? We will get that ms square x cube divided by x power 4 m power 4 x power 4 ms square okay. So x cube will be cancelled, then we will get this one. Is it fine? Is it fine or not? Please tell me.
Yes, sir.
Mm, 1 minute, some problem. Yeah, okay. But when we'll put that x equal to 0, then what will get? X equal to 0, then this is this fine, this one? Because if here if you put x equal to 0, we are getting 0, but here this is some okay, we are putting x equal to 0 and y equal also non-zero. That time we are getting 0. Is it or not? This quantity is fine.
Sir, it is undefined.
Yeah, when we are going approaching to x equal to 0. So from here we can't say anything. Okay, so we have to choose another path. Okay, so try this one at first. So our basic path, this one, when x is not equal to 0, what we will get? Y is 0 means we will get 0. Okay, and with this path also, when you are not equal to 0, we are getting limit is also 0. From here also we can conclude anything. Okay, but choose this path, x equal to y square. Hey, 1 minute, I think I did some mistake here. I think this should be square, I think. Then it will be fine. Yeah, this should be square, I think. This should be square. Please change it, sorry. Yeah, then it will be good, I think. Yes, this will be your x, this will be 1. Now is it fine?
Fine.
Yeah, but in this case also, these quantities depend on x. So from here also we can conclude anything. From this situation also we can conclude anything. When your y equal to mx, you put this path, this is depend on your x. So we was looking for independent of x, but here this quantity is fully depend on x. So from this path also we can say anything properly. Only one can think, or one can tell about that when x is approaching 0, we will get the limit is 0. This one we can tell. Yeah, from here easily. Okay, when someone put the x equal to 0, we will get the limit is 0. But if someone choose this path x equal to y square, then what will get? Y square y. What will get? X means this is y4, after that y4 plus y4, is it? So we are getting half. So when your function is approaching, okay, not function, when your xy is approaching to 0 0 with this line, okay, with this curve, with this path, sorry, with this path, then your limit of this function is going to half. Okay, but for these two cases your limiting value was 0. So using along this path your limiting value is 0, and along this path your limiting value is half. Both are different, so the limit of the function is does not exist. Okay, is it fine? So sometime also you have to choose path like that, depend on your question. So here this one is a square, this one is 4. Okay, so we can take the common. This is not the concept, but usually one can observe from the questions. Okay, is it fine or not? Please tell me. Is it fine?
Fine, sir.
Okay, so now we'll go for algebra of limits. Okay, this is same as one variable functions. Okay, yeah, I will not mention properly, I will tell you only. Okay, algebra of limit. Okay, so this is same as your one variable functions. So if you multiply one functions by a real number, what will be the limit of the product of this one? We already know. Okay, so what will be the product of this one? Suppose, yeah, limit of f of xy into, what will be this one? This will be, the limit will be what? This limit will be f of xy into limit of this one. Okay, when your xy is tends to some value. This is same as your one variable. Okay, subtraction, addition, multiplication, everything will be follow similar as one variable function. So I will not go for these things. Okay, so we want to go for so now we'll look for continuity. Okay, continuity. So could you please tell me what is the definition of continuity of a single variable function? Yeah, please tell someone. Suraj?
Yes, sir.
Yeah, let's try to tell me what is the definition of continuity.
सर लिमिट एग्जिस्ट होना चाहिए और एफ एक्स इक्वल टू रियल वैल्यू होना चाहिए इसमें.
Yeah, so this is same as that your limit has to be exist, okay, and suppose we are looking for one quantitative function at a point A. That time f of A means functional value at the point A is should be well defined, or is it, if you tell defined is fine, and these two should be equal. Limit of f of x at the point AB it should be equal to f of AB. This same thing will hold for two variable function also. Suppose you have one function, so its domain defined from D to R, okay. F is continuous at AB, okay, which belongs to D, if the following are satisfied, okay. Following are satisfied. One is f of AB must be well defined, okay, or define, whatever you want you can call it, okay, when your AB belongs to D, okay. And second one is limit of f of xy must be exist, okay, when your xy is approaching to AB. Third one is limiting value of x1 must be equal to f of AB when this one is approaching to your AB. So these three conditions has to be satisfied by the functions, okay. So f of AB is must be defined, and limit of that function when xy is approaching to AB must be exist. Third one is the limit of the function, okay, at the point AB must be equal to f of AB, okay. So now we'll look for an algebra of continuous function is same as algebra of limits, okay. Only one things I want to mention, that polynomial in two variable, okay. Polynomial in one variable, if you talk, this is a continuous function. I think everyone knows about that. And if you talk about polynomial in two variable, this is one example of continuous functions, okay. Is it fine? Is it fine for everyone? Are you familiar with that? What is a polynomial or all those things? And second one is rational functions. What is the rational function? It's nothing but a ratio of polynomial, okay. Is it fine? So these two are example of a continuous function. This is for n variable also, so not for 1, 2 like that. For n variable, these two are very important and basic basic example of continuous functions, okay. Right now please try to check one example that is given. F of xy is equal to 3x square y by x square plus y square when is your this one is non-zero, and 0 if 0, 0. Is it continuous on R2 or not? You have to check it, okay. Please tell me what is your guess. At first please tell me what will be limit when xy will be approached to 0 0. Please tell me what would be the limit. You can guess from here, because we already know if function is continuous at a point AB, that should be equal to the functional value at the point AB. Okay, yeah. So one guess is this limit is 0. Okay, so could you please tell me what will be the epsilon delta here? So take epsilon is greater than 0 be given. Okay, is given. Okay, we have to find delta. So could you please tell me what is the guess for delta? We already did similar example previously. Okay. You have to choose delta. We have to
epsilon upon 3.
yes, delta such that this should be less than delta. Okay, so our obvious choice is delta equal to epsilon by 3, because from here we can guess it. Okay, so here your 3x square by y, this is all given. Okay, this is less equal to nothing but we can write this one is as a x square plus y square. Okay, so from here we can write it as 3 mod y. Okay, this one, and mod y is also less equal to 3 root over x square plus y square. Okay, so this is obvious choice. 3 into 3 by epsilon is your delta. Okay, yeah, someone can check it. So here we can say that limit of the function f of x is 0. Okay, when xy is approaching to 0 0. Okay, and it is also given that function value at the point 0 0 is 0 is satisfy all the condition of continuity. So function is continuous at the point 0 0. And for other point you can check easily that this is a rational function. Okay, this quantity is a polynomial of 2 variable, this also polynomial of 2 variable, and except the point 0 0 everywhere this quantity is this denominator is non-zero always. So this division is exists, this is a rational function. So at the point except the point 0 0 everywhere this function is continuous. So this function is continuous on R2. Okay, is it fine or not? Please tell me.
Fine, sir.
Okay. I will discuss one last example, then we will stop our discussion for today. Okay, yeah, try to, I will not help you, you have to do by own. Okay, xy x square minus y square divided by x square plus y square whenever this quantity is non-zero is 0 when, yeah, please tell me, is it continuous or not? Okay, continuous on R2 or not? Please tell me. Yeah, what is your guess? Yeah, please tell me what is your guess? one observation is that is very clear that x square is minus y square is always less equal to x square plus y square. What about this product? Please tell.
Limit not exist, sir.
Sorry? Please tell.
Limit not exist.
Limit does not exist.
Yes, sir.
Why?
Sir, x square minus y square. Then, sir, sigma non zero आ जा रहा है.
I could not understand. Your claim is limit is does not exist. Is it? Suraj?
Try best, sir.
Yeah. Okay. So I am giving one hint. Limit is exist and equal to 0. Okay. So how you will proceed? Please tell me. Choose one epsilon greater than 0. You have to choose delta. How? So this is very obvious. Is it or not? This one. This one is obvious. So what about this quantity? What about this quantity? X into y.
And under root x square plus y square upon 2.
Can I write this one? Please tell me, can you write this one or not?
Yes.
Yeah, because from here you will get this quantity is always your greater equal to 0. Okay?
Okay, sir.
Yeah. So from here you will get this one, this quantity, no issue. So use this one, this two. Then what we will get? We are getting that mod of xy minus 0 equal to xy x square minus y square divided by x square plus y square. This is less equal to x square plus y into x square plus y square divided by, so this equal to nothing but x square plus y square. Okay, so what is your guess about delta? Please tell me. Delta have to satisfy this one, na? Yeah, this one you have to satisfy. So what is your
Epsilon into delta square.
Yeah, this one. Is it fine for everyone? Is it fine or not? Please tell me.
Fine, sir.
Yeah. So yeah, limit of this function is 0. Okay. Limit xy tends to 0, 0, f of xy equal to 0, and at the point 0 also is also defined and 0, and this is equal to f of 0, 0. So function is continuous at the point 0, 0. Okay. Is it fine or not? So do you have any questions? So you can proceed right now. Yeah, please tell me. Do you have any question or not? Do you have any question?
Yes, sir.
Please tell. Proceed.